On page 773, we have 3 learning targets. Because there are 3 different types of polygons we're going to find the areas of. We're going to find the areas of trapezoids and of rhombi or rhombuses and kites. So let's see how this works out. All right, we know what a trapezoid is. It's a 4-sided figure, a quadrilateral, with exactly 1 pair of parallel sides. Not 2, because then it'd be a parallelogram. 1 pair of parallel sides. All right? Those have to be the bases. Okay? The parallel sides are the bases. The height of the trapezoid is the perpendicular distance between its bases, like it was with the parallelogram. So the height will not only be perpendicular to one of the bases, it'll actually be perpendicular to both of them. So as long as you make it perpendicular to one of them, you're good. It'll automatically be perpendicular to the other one. Okay? This is in the figure below. So take a look at this figure. A glide reflection, so we have to scoot it over, then flip it over, of the first trapezoids results in 2 congruent trapezoids that fit together to form a parallelogram. So they started with this trapezoid, they cloned it, they scooted it over, flipped it over, and this other trapezoid is identical to it. They're congruent. Then, when you mash them together, that's a parallelogram. Okay? Assuming now there's not actually a gap between them. You put them up together so there's no gap between them. All right, and then look at it. What's the height of, or no, I said that wrong. What's the length of one of the bases of this brand new parallelogram? Well, it's the original little base plus the original other base. So it's one of the bases plus the other base for the original trapezoid. So it's B1 plus B2. Now, since it's a parallelogram now, because we've mashed them together, the area is base times height. So there's the base. The height would be the original height of the first trapezoid, right? So times the height, and that's the area of the parallelogram. Get rid of one of them, and since they were congruent to start with, isn't the area of what's left half the area of that parallelogram? So throw in a 1/2. Now, it's common practice to put the H in front of the parentheses instead of behind it. So here's the formula for the area of a trapezoid that we're going to use. Area equals 1/2 times the height times the sum of the bases. 1/2 times the height times the sum of the bases. Okay? Doesn't matter which one you call B1 and which one you call B2. One of the bases is B1, the other base is B2. Okay? So area equals 1/2 times the height times the sum of the bases. And then look, we're going to work the same kind of problems that we did with parallelograms and triangles. Sometimes it's really straightforward. If they happen to give us all of those measures, it's just an arithmetic problem. They won't always give us all of those measures, will they? We'll have to work for them. They'll give us special triangles. Well, right triangles will be the key, won't it? Because like they've drawn here on the theorem itself, they put the height right there so that we get a right triangle. Because look, we could put the height right there. It's still perpendicular to both the bases. It's still the height. It's just not near as useful there. Okay, there's nothing wrong with it being there other than by putting it over here, it leads us to having a right triangle to work with, and we're pretty good at that. Okay? All right, so let's see what kind of thing we're going to do. Let's start with an easy one. On page 777, wow, they give us everything we need, don't they? So, area equals 1/2 times the height times the sum of the bases. So area equals 1/2 times 12 times the sum of the bases, which would be 16 plus 6. And then you can make this take as few steps as you want from here on out. I'll go ahead and show you everything I can. What's working your parentheses? What's 16 plus 6? 22. Then you can do 1/2 times 12 is 6. Even I wouldn't write that down. So at this point, let's multiply it out. 1/2 times 12 is 6. And 6 times 22 is 132. So our area equals 132 square feet squared. All right? So, not so bad. Let's see if we can find one more challenging. All right, skip ahead a bit to number 4. Suki is doing fashion design at 4-H Club. Her first project is to make a simple A-line skirt. How much fabric will she need according to the design at the right? So the blue figure is a trapezoid. So let's try to find the area of that trapezoid. Okay? So let's see here. I know that the area of the trapezoid is 1/2 times the height times the sum of the bases. I need to try to decipher all of this information on here to find all of these things. So 1/2. All right, what's the height of that blue trapezoid? It's 2.5 feet. Now, they wrote it over here, but since it goes from here to here, that is the length. 2.5 is the length of that red segment right there, isn't it? Which is the height. So the height is 2.5. I think I'll go 2.5 times. All right, what's the length of the base at the top of the trapezoid? 1.5. So let's go with 1.5 plus, and then what's the length of the base at the bottom of the trapezoid? 2. It's 1.5 plus 1/4 plus 1/4. So it's 2. All right. Now, I know that 1.5 plus 2 is 3.5, and then I might as well use my calculator. So I'll do 0.5 times 2.5 times 3.5. And I get 4.375 square feet. And then, just because I tend to do this, I look over here at my book where the answers are. That's not the answer. Why isn't that the answer? Even if I put that in a fraction, it's not the answer. They say that it's 8 3/4 square feet. Yeah. See, I didn't know this about A-line skirts, and I guess you don't either. Evidently, you take 2 trapezoids and you sew them together to make the skirt. So that's only half a skirt. So, ladies, don't wear this one. It's just half a skirt. So let's turn it into a whole skirt. So skirt area equals 2 times 4.375 square feet. And so 4.375 times 2, and that's the 8 3/4 that the book wanted. So 8.75 square feet. Now, on a quiz, I'm not going to ask you a question where you can only get it right if you happen to know how to make an A-line skirt. Okay? But, that's kind of the trouble with leaving a made-up math textbook problem and actually trying to apply it, is you kind of have to know what you're talking about. And none of us did. Yeah. You know, I'm kind of regretting not going to 4-H camp 40 years ago when I had the chance. All right. Let's see how rhombi and kites, or as they call it here with a typo, a rhombus. All right, now, a rhombus is a parallelogram. Can we use area equals base times height to find the area of a rhombus? Yeah, because it's a parallelogram. But it also works this way, all right? It also works that the area of a rhombus is 1/2 times the length of one of the diagonals times the length of the other diagonal. And surprisingly enough, at least it is to me, that same formula works for a kite. 1/2 times the length of one diagonal times the length of the other diagonal. So that formula works for a rhombus and it works for a kite. All right. Let's see how we use this. Number 2. So back up and let's get 2 and 3 that we skipped before. Now, number 2, the directions say find the area of each trapezoid, rhombus, or kite. So it's definitely not a trapezoid. It's a rhombus, but even if it weren't, it's either a rhombus or a kite, right? So use the fact that the directions say that to clue you in to what kind of figure you have. Because if just out of the blue I give you that figure, you know, don't assume it's a rhombus. But we're not directly told, but we're indirectly told that must be a rhombus. So let's find its area. 1/2 times diagonal 1 times diagonal 2. Can it be that simple? What's the length of one diagonal? 18. It really is. From there to there is 18. They didn't draw the diagonal in, but isn't the diagonal the distance from one vertex to the opposite vertex? So it's 18. And the length of the other diagonal? 10. Half of 18 is 9. 9 times 10 is 90 meters squared. Bet you can't do number 3. Did you get what I got? Now look, these aren't any fun at all, are they? They're giving us too much information. They're making it too easy. It's not perfect. It's too easy. All right. So if they give us a formula and they give us the information that all we have to do is plug it into the formula, we're golden, right? Okay. Now, problems that are a lot more fun are ones like 5 and 6 and 7, where we have to do a little work. So number 5, they tell us to find x. And x, if you look at the figure, you realize is the height of that trapezoid. So let's start with the formula. Area equals 1/2 times the height times the sum of the bases. And then let's fill in, let's substitute in the information that we know. Replace capital A with 78. replace h with x, and then replace b1 and b2 with 6.4 and 13. All right. I'm going to work inside my parentheses first. So I'm going to have 78 equals 1 half x times, and then, oh, it's adding. So that'd be what? 19.4. Okay. Now, what to do with that 1 half? Well, I can multiply both sides by 2 if I want to, right, in clear fractions. But if I multiply 1 half times 19.4, is that going to give me something fairly good to work with or something horrible to work with? Fairly good, I think, since 19.4 is even. 0.5 times 19.4. Yeah, that's fine. So 78 equals 9.7x. And I've simplified as much as I can. I'm back to the old simplify before you solve, right? I simplified everything I can. All I got to do now is divide. So 78 divided by 9.7. All right, did they tell us where to round? They don't. Let's go hundredths, just for fun. So 8.04, ooh, I need to put a unit on there. Square centimeters? Just centimeters, because it was a linear measure. It's the height. Equals x. Any questions on 5? Probably not. I'm just not sure they're always going to do that. So I want to stick in the habit. Now that we're doing, in fact, when we're doing volumes in the next unit too, I'm going to try to always remember to put a unit on there, because it can get confusing when you're dealing with squares or linear or, heavens to Betsy, cube meters. So we'll stick with it. All right, number 6. What kind of figure is it? Even though I wrote the learning target right above it that said find areas of rhombi. How do I know it's a rhombus? All right. Its diagonals bisect each other, so it's a parallelogram. And then my next clue is, oh, this is the rhombus section. Okay? So, area equals 1 half diagonal 1 times diagonal 2. So, replace A with 96 equals 1 half. All right, we know this part right here is 7.3. But 7.3 is not the length of that diagonal. What's the length of that diagonal? 14.6. Right? Because the diagonal got bisected by the other one. Now, if this is x inches, what's the length of that diagonal? It's 2x. Everybody with me on the substitution? All right, so that's actually good news, because the 1 half times the 2x is an x. So I get 14.6x. And I just have to divide. 96 divided by 14.6. And to the nearest hundredth, what is that? 6.58. And we'll go ahead and say inches to the nearest hundredth. Yeah. Yep. All right. Give number 7 a whirl and see what happens. Anybody get the same thing I did? Any questions? All right. If and when you get confused as to what formula goes with what kind of figure, they have a summary at the bottom of page 776 that tells you, okay? And I do expect you to know these formulas. Usually on a standardized test, they will give you the formulas like this you need, but you guys need to know these formulas, okay? So make sure that you do. And your assignment is this. On page 777, do 1 through 21, 26, 27, 30 through 32, 34, 37, and 39 through 44.